In this video, we will see how to design a decade counter using Embedded C. We will use the concept from the previous lecture, that is using switch and a function in Embedded C, and will apply a for loop and design a counter that counts from 0 to 9. So the hardware setup, that is the data direction part, will remain the same in this video also. That is, the 7 segments will be connected from 2 to 8 pins on the Arduino board. That is like A to B on the 7 segment will be connected to 2 to 7 respectively on the Arduino. So we'll start with the programming. Go to the terminal, type Genie. It will open an editor. Take a new script and start with the programming. Hash include avrio.h, hash include util delay.h. Then I told we'll be using the same concept from the previous one. So I'll be using the same 7 segment program, same 7 segment function here. So 7 segment int. I'll start the main program. So the declaration will be extra, that is, as I'm using for loop, I need to declare one more integer called I, and the other things remains similar. So ddrd equals 0b 1111. So the first pin, that is first bit on the port D will be high, so 0b. So this is it. So once this is done, I'll write while true. So here I'll include the for loop to make it a decade counter. So for loop has 3 segments. One is the initialization. So I'll initialize I to 0. The next one is the condition. As I'm using a decade counter, that is, it will count from 0 to 9 because I'm using only one 7 segment. So I can display numbers from 0 to 9. So the condition will be I when I will be less than 10. So which means that for I is equals to less than 10 times, the for loop will be executed. So once the I is equals to 10, it comes out of the for loop. So next will be the increment. In for loop, I'll call the 7 segment function. So 7 seg, I'll give it to I. So I'll close for, I'll close while, I'll return 0, and I'll close main. Next will be the void segment function. Start with the programming. Hash include avrio.h, hash include util delay dot h as I told, we will be using a function with no return value but a one input value. So I'll write that function. I'll name that function as a 7 segment. So I will write void, that is no return value. I'll write the function name as 7 segment, and I'll give one input value, that is integer value will be my input value. Then I'll start my main program. So int main void. So as I told here, we will be using these pins. So that is pin 2 to 7 from the port D and 0th pin from the port B. So first we need to declare the data direction register. So I'll write DDRD equals 0B. I'll make all the ports from port D as output ports. So 1, 4, 8 pins will be high, and I want only the 0th pin from the port B to be my output port. So DDRB is equals 0B 0000000, and my first bit, that is 0th pin will be my output pin. So once this is declared, I'll go for the while loop. So while the condition is true, I'll call my function, that is 7 segment function. I'll call and I'll give any integer value. Like for in this example, I'm calling it to switch to the 7. I'm giving an input value 3. Okay, I'll input value 7, and once in this we'll see what we are writing into this program later on. So first I'll complete the main part, then I'll explain how the function is defined and how the switch is used in that function. So I'll close my while loop, then I'll return 0, and I'll close my main program. So once this is done, my main program is done. Now the thing is how to declare this 7 segment function. So I'll write the 7 segment function here, void 7 segment, and what is it, integer in decimal values. I have given a variable name called DEC. DEC is my variable name which holds the value of integer, that is this 7 or 3 or whatever we are giving here, which number we want to display it on my 7 segment, that number I should give it here. So I'm taking that value in this decimal integer. Next in here in this function, I'll close and open the braces. So this will be my function. So in between this I'll be writing my 7 segment function. So in this function I'm going to use my switch case. So I'll write switch decimal, because I'm going to use this decimal value to switch my cases, that is like to print my values, I'll be using this decimal variable. So switch decimal and open brace and the closing brace. So in this I'll write my switch case. So first will be a case 0, right? So what will be the case 0? So I need one more table here. So to print 0, what should be my inputs? All the pins should be low except to the pin G, and I have shown it in this image. where is my pin G connected? Pin G is connected to the 0th pin on the port B, and rest all connected to the port D. So I will write here. So I'll make it clear for you. So okay, for my case 0, what will be my inputs? G should be high and the rest all should be 0. So first I'll write it for port D. Port D is equals to all pins should be high. So 0B 0 0 0 0 0 0 0 0. And from port B it should be 0th pin high. So this is it, and then we will give a break. So break is a part of my switch condition. Okay. So next to display, next case will be my 1 case. So for 1, D, E, F, G should be and A should be high and B and C should be low. So I'll write it for case 1. What will be there for my case 1? Port, first I'll write it for port D. So port D, it should be 0B 1 1 1 0 0, again 1 1 1. Next in port B, it will be 0B, all should be high. Okay, next I will break this 1 case. Next case will be my third case, that is for displaying number 2. So remember that this colon and this break condition, writing a break statement are necessary for the switch conditions. So for case 2, my port D, we can see here for 2, A, B, D, E, G should be low and C and F should be high. So my port D will be 0B 1 0 0 1 0 0 0 0, and in port B will be 0B all zeros. Next, break the statement. Again for my case 3. Case 3 will be port D equals 0B 1 1 0 0 0 0 0 0. Port B equals 0B all zeros. Next will be for my, sorry, I have missed the break here. So break. Next for the case 4, it will be port D equals 0B 1 0 1 1 0 0 1 1 0 1 1 1 1 1 1. Next comes the port B, which is equals to all zeros. 0B. Next, break this statement. Break the case. Next will be my case 5. Port D equals, so for 5 to display B and E should be high. So B is my third PD3 and E is sixth pin. So port D will be 0B 0 0 0 0 1 1 0 0. PD 3 and PD for 5 B. So B will be here. PD 3. So PD 0 1 2 3. 0 1 2 3 will be high, and E is PD 6. So PD 6 will be 1. So PD 6 will be 1 and zero 0 0 1 0 0 1 0 1 1 0 1 1 0 0 1 0 0 0 1 0 0 1 0 1. Yeah. Next it will be port B equals 0B, all zeros. Break. Next is case 6. Port D equals 0B 0 0 0 0 0 0 0 0 1 1 0 0, and port B equals 0B, all zeros. Next, break this case. Break backspace case 7. So for case 7, it will be D, E, F, G will be high and ABC will be low. So ABC will be low. So P2 to 4 will be low, and PD 5 to 7 will be high, and PB 0 will be high. So port D equals 0B 1 1 1 0 0 0 0 and port B will be equals to 0B 0 0 0 0 0 0 1. Break. So here we are writing the G pin high, right? So PB0 will be 1. So break, and then for case 8, and for case 8 all pins should be high. So port D equals 0B 0000 0000, and same with the port B also. So port B equals to 0B 000000. Next break. Next will be for my case 9. So port D equals 0B 01 100000, and port B will be all zeros. Case 9, break this statement. Then we need to write a default for the break statement. This is compulsory statement for the switch. So for in default, I'll give the output for the 0. In default, I'll put 0. So port B is equal to, all pins will be high. That is, all pins will glow. Equal 0B 1 and break. So, and as I'm using a decade counter, I need to write the delay here, because if we are missing this, we cannot see the output. So it is mandatory to put a delay here. So delay ms 1000, as I want to print the values from 0 to 9 at a delay of 1 second. I'm giving the delay of 1000 milliseconds. So once the program is done, I'll save it, Control yes, I'll save it in the tree as counter for .c, because I'm using for loop. Just for easy remembrance, I'm giving it this way. So these are the hardware components required for the setup. So let's begin the connection as shown in the truth table. So let's first connect the second pin on the Arduino to the A pin on the 7th segment, third pin on the Arduino to the B pin on the 7th segment, fourth pin on the Arduino to the C pin on the 7th segment. Next, connect the COM pin on the 7th segment to one side of the breadboard. So we should connect VCC 5 volts to this pin. So let's connect that to the VCC here. Next, connect 5th pin on the Arduino to the D pin on the 7th segment, 6th pin on the Arduino to the E pin on the 7th segment, 7th pin from the Arduino to the F pin on the 7th segment, 8th pin on the Arduino to the G pin on the 7th segment. So once the hardware is complete, we'll plug the Arduino to the board. So I'll go to the directory and I'll type make fname equals counter for, and I'll hit enter. We can see that some amount of flash has been written and the number started displaying from 0 to 9 on the 7 segment display.